Okay, this is problem 5-14. Here you have 9 horsepower and you're spinning at 27 revolutions per minute. So the first thing you need to do with these type of problems would be to get this, and you want to get the angular velocity or angular speed into radians per second. So what you're going to do is take 27 revolutions over minute, and then 1 revolution is equal to 2 pi radians. So you put your 2 pi radians up here, and you can put radians if you want to, you don't have to, over 1 revolution. At this point, revolutions will cancel out. Now you need to get the minutes into seconds. Put 1 minute up here, 60 seconds down here. Minutes cancel out. Do that red. Minutes cancel out here and here. And now what you're left with is 27 times 2 pi radians per second. And that gives us 2.8274 radians per second. Alright, so that's omega. And now all we have to do is, this is given in the textbook, the power is equal to torque times omega. So all we have to do then is determine what the torque is. Now we have 9 horsepower. Now think about horsepower. You need to get this power into foot-pounds per second. So what you're going to do is there is 1 horsepower is equal to, or in, 550 foot-pounds per second. So we'll do this conversion here. So I got 9, this looks like an R, doesn't it? Horsepower. I don't know, did I say hour here? That's horsepower, sorry. Okay, excuse me. Alright, so we're going to go ahead and multiply that by 550 foot-pounds per second, and we'll divide that by 1 horsepower. Horsepowers cancel out. Okay, when we run that calculation, we'll get 4,950 foot-pounds per second. Okay, so that's what my power is. So now we're going to use this equation right here, and we'll put 4,950 foot-pounds per second is equal to our torque times our omega, 274 radians. I need to put seconds down here too, sorry, foot-pounds per second, over radians per second. Let's see, that was supposed to be a 4. Let me change that, looks nasty. 274 radians per second. We're going to solve for t, and when we solve for t, we will get the seconds will cancel out. So that's going to give me 1,750.7 foot-pounds. So that is what our torque is. Okay, so now we can just go back to the equation that I'm going to scroll down. Go back to the equation that we know that shear stress, especially max shear stress, is going to equal to torque times the radius, or c, either one you want to use, divided by the polar moment inertia. And we're going to let c be the furthest out on the shaft as we possibly can. In this case, c will represent 1.25, the distance from the center out to there. We'll put c is equal to 1.25. Okay, now in this problem you're given T max, and the maximum allowable is 10 KSI. So write that as 10 times 10 to the third. We know the torque is going to be 1750.7. multiply it by the maximum radius, and then we divide it by the polar moment inertia, but again we have a hollow shaft. We know the one diameter, we just need to find the other one. So we use the radius, which is 1.25 to the fourth power minus, we'll call it, you can call it RCI or RI, I'll call it RI, the inside radius to the fourth power. And now all we have to do is solve for that. So we're going to bring this, basically I'm going to bring all this up to here and then bring this down to here. When I do that, I will get 1.25 to the fourth minus R inside radius to the fourth is equal to 1750.7 times 1.25 over pi over 2 times 10 times 10 to the third. Put that in parentheses. And now I want to move this to the other side, so I'm going to subtract 1.25 to the fourth, which will get rid of it on this side. And now I have a negative, so I'm going to multiply everything by negative. We'll do that in red. That'll be negative. That becomes a plus. Now get rid of this on this side. Now we'll have to do solve for Ri. That means we're going to take everything on the right side to the 1/4 power. Put those in parentheses. Put the 1/4 power here. And then this will cancel out. And then when we do that, our final answer, or actually our Ri value, inside radius, comes up to be 0.9366. Let's go down a little bit. So then they want the diameter, and the diameter, inside diameter, to be double that, which will give me 1.873 inches. And that's our correct answer, where you can convert that. Since they said, let's see what it said actually. Determine the inner diameter of the tube to the nearest 1/8. Okay, so we're going to go back to the nearest 1/8. Alright, so what we want to do here, we do not want to round up, we want to round down. So di in this case would equal to 1.75 inches. Okay, so that problem wasn't too bad at all. Hope that helps.